I'm going to start by differentiating my substitution. So differentiating u with respect to x, differentiating the tan, I'll get sec squared x. Now making dx the subject, I'm going to say that du over sec squared x is equal to dx, which in a moment is going to allow me to change this dx to be a du over sec squared. We'll come back to that in a moment. Let's now have a look at these limits. So upper limit first, so when x is pi over 4, u is going to be equal to tan pi over 4, which is just 1. So my upper limit in the u world is 1. What about the lower limit? That was when x was minus pi over 4. So let's substitute that into my u function to get tan of minus pi over 4. And that gives me minus 1. So my lower limit is going to be minus 1. Right, let's make those changes to the integral then. My lower limit is minus 1, the upper limit is 1. I'm going to leave the tan squared x and the sec squared x there for a moment. I'll change those into the u world in a minute. Let me just change the limits in my dx first. Because now I can see that the sec squared here and the sec squared there are going to cancel out. So I don't need to worry about those parts of the integral. The only part I need to worry about is, well, what is tan squared in the u world? Well, I know that that's going to be equal to u squared. So after all that, we've just got the integral of u squared, which is 1/3 u cubed. Substituting 1 into that, I get 1/3 times 1 cubed. Now substituting minus 1 into that, which gives me 1/3 minus minus 1/3, which is 2/3.